Why are bridges made up of steel instead of the pure iron? Why does copper conduct electricity so well? And what makes sodium explode in the presence of water? Welcome back, science explorers. Today we are going to unlock the secrets of metal. What are the special properties of metal which makes it so essential in the modern lives? So let's fire up the furnaces of our curiosity and let's hammer this topic into shape. So before we dive into this chapter, let's first look out for all the topics which we are going to cover in this particular video. So first we are going to talk about your physical properties of metal and non-metal, then properties, individual properties of both of them. Then we will talk about the chemical properties, how do metals react with oxygen and with other things, then uses of metal, then we will talk about what are alloys and what are their properties, then the structure of an alloy. So I hope you are ready to dive into this chapter. So the first is metals and non-metals. So many times we have seen this periodic table and we have discussed that metals are placed at the left side of the periodic table. This is all your reactive metal. This is alkali metal group 1, alkaline earth metal group 2, and then these are all your non-metals, okay? And here are the rest of the metals which are placed, okay? Now, placement we already know. So there are around 118 elements in the periodic table and they can broadly be classified into metals and non-metals. Although there are metalloids which are also present, they possess the properties of both metals and non-metals, like for example silicon, okay? Most of the elements are metals and a small number of elements display properties of both type. These elements are called your metalloids or your semi-metals, okay? Next, this is your transition metals, okay? The one which is placed between your group 2 and your group 3. These are your transition metals, okay? Next, let's talk about the physical properties of metals and non-metals and let's try to differentiate between both of them. Okay, so first thing is melting and boiling point. So we know that metals are hard substances. Okay, of course, there are few exceptions like for example, mercury, okay, or we can say gallium or cesium. Okay, so they are soft. Also your alkali metal, the group 1 metals are your soft, which can be cut by a knife. For example, sodium or potassium. But generally, if we see, metals are hard, and because they are hard and they are solid, therefore metals are usually solid except for mercury, which is liquid at the room temperature. Many metals have high melting and boiling point. Okay, so they usually possess high melting and boiling point. Next is your non-metals. Now non-metals have variable states in which they can occur, like for example solid, liquid and gas. So they can occur as gas, they can also occur as a liquid, like for example your Br2. This is an exception. So Br2 bromine, which is a liquid non-metal, which is reddish brown in color. Okay, their melting and boiling point are often low. Okay, so the values of their melting and boiling point are low for non-metals. Next is their electrical conductivity. We know that metals are very good conductor of heat and electricity. Exception is there, which is your lead and Hg. Okay, so let me write down over here. Exceptions are Pb, which is lead, and Hg, which is your mercury. Okay, next, non-metals are poor conductor of electricity, but then there are exceptions, which are your graphite. Okay, graphite is an exception, which is good conductor of electricity. Okay, rest all of them are insulators. Next is thermal conductivity. Metals are good conductor of heat except these two. Exception is here also. Then non-metal are generally poor thermal conductor except your diamond. Diamond is a very good conductor of heat, okay, which conducts heat strongly. Okay, next is your malleability and ductility. Now, malleability and ductility are the properties of metals. Malleability means that it can be beaten down to form thin sheets, and ductility means that they metals can be like made, the wires or thin wires can be made out of metals. Okay, so the shape of a piece of metal can be changed by hammering. They can also be pulled out with the into the wires, which is ductility. Okay, so metals show good property of malleability and ductility except mercury, because mercury is your liquid. Next is non-metal are not malleable, they are brittle and break easily when hit, right? Next, strength and hardness. So metals are usually strong and dense. This we have already talked about. Sodium, potassium and other alkali metals are soft. They can be cut by a knife, and other than this, your mercury is liquid. Therefore, these are weak, but generally metals are strong and dense. When a force is applied, they are hard and do not shatter, right? Most non-metals are soft than metals, but there is an exception, which is diamond. Diamond is the hardest element, or diamond is the hardest which is found in the earth. Okay, their densities are often low. The densities of your non-metal is often low. Next is ability to produce a sound, or we can say that how sonorous they are. Metals usually make a ringing sound when struck. They are sonorous. Okay. Next is non-metals are non-sonorous. Next is color and appearance. Metals have shiny appearance to it. Okay. Metals are generally gray in color except gold and copper. They can be polished. Non-metals vary in color. They often have a dull surface when solid. But there is an exception in the case of your non-metals. Exception is graphite and iodine. Okay, so iodine is bluish black solid and it has shine on its surface, and also graphite. So this is basically the differentiating properties between metals and non-metals along with the exceptions. So please take a minute here to note down this. So this was your physical properties of metals and non-metals. Now let's talk about the chemical properties. Okay, so chemical properties of metal. So we have heard of the reactivity series, and the mnemonic was also shared with you in the previous chapters. The mnemonic was, please stop calling me a careless zebra, instead try learning how copper saves gold. Okay, so this was the mnemonic. This is the reactivity series. Reactivity series gives us an idea that which metal or which element is more reactive and which one are the less reactive. Okay, so the one which are placed at the top are the more reactive elements. They react very quickly and very easily, and the ones which are placed at the bottom are the ones which do not react easily. Okay, now let's talk about the chemical properties of the metals now. So as we go down the reactivity series, the reactivity decreases. Basically they will not react easily, right? So when we talk about the reaction of metal with, first is air, then second we will talk about water, and then their reaction with dilute HCl. Okay, so what happens? This is the reactivity series. As we go down the group, their reactivity should decrease. Okay, so let's see how sodium, calcium and magnesium, these three will react with air. So they will burn very strongly because they are very reactive in air to form oxide. What about aluminium, zinc and iron? Burn less strongly in air to form oxide. Okay, because they are less reactive comparatively. Then these lead, copper react slowly to form oxide layer when heated, and silver, gold, they do not react because they are less reactive. Then let's talk about them, the reaction of these metals with water. So they react with cold water to give hydrogen. Okay, then they react with steam when heated to give hydrogen, and here they do not react. You can see as we go down, they do not react at all, the silver and gold. Okay, then when we talk about their reaction with HCl, which is hydrochloric acid, then they react very strongly. The ones which are at the top of the reactivity series, then they will react less strongly, and then do not react. So here this concludes that as we go down the group in the reactivity series, their reaction decreases. Okay, or the rate of reaction will decrease when it comes to air or water or dilute hydrochloric acid. Okay, now let's check the reactions in detail. So when metal reacts with water, it will give us metal hydroxide plus hydrogen. So this is the skeletal reaction. So let me write down, M plus H2O gives MOH, which is your hydroxide, plus hydrogen gas, which is H2. Right, this is the skeletal reaction. Now look at the reactions. The more reactive metal will react with cold water. So the one which are placed at the top of the reactivity series, they will react with the cold water also to form a metal hydroxide and hydrogen gas. Potassium, sodium, calcium all undergo reaction with cold water as they are the most reactive. So because they are the most reactive, they will react with cold water. For example, when we react calcium with water, then potassium, then sodium, we will get their hydroxides, okay, and along with that hydrogen gas will be released. So let me show you the reactivity series again here. So we are talking about sodium, calcium and magnesium. All these three will react with cold water and they will give us hydroxide and hydrogen gas, okay. Next is reactions of metal with steam. Now the metals which lie below the most reactive, they react with steam. Like for example magnesium. Metals just below calcium in the reactivity series do not react with cold water but will react with steam to form a metal oxide. Now they will not form a hydroxide but they will form a oxide. For example, your magnesium. Magnesium reacts with water to give MgO plus H2. I hope this is clear. So the ones which lie below calcium, I will show you. Which lies below calcium, so which lies, okay. So these three are the most reactive. They react with cold water, cold H2O to give MOH, which is hydroxide, okay. But the ones which lie below calcium, like for example magnesium, they react with water, they react with steam, not cold water, to give what? Metal oxide, not metal hydroxide, right? So the reaction for this will be, or skeletal reaction for this will be MO, metal oxide, and not hydroxide, plus H2. I hope this is clear. Now look at these reactions. The elements are given to us: lithium, sodium, potassium. This is your group 1 element, and as we go down the group, the reactivity increases, right? We know that because metal 1 or the group 1 are all the metals, and metals have tendency to lose electrons. So as we go down the group, their size increases, the nuclear force of attraction decreases, therefore it is easier to lose electron. Hence the reactivity increases as we go down the group. So how do they react? Let's see. Lithium reacts with water to give LiOH, which is lithium hydroxide. Tarnishes slowly to give a layer of oxide. Then sodium reacts, tarnishes quickly to give a layer of oxide. Then potassium reacts, which lies below sodium, therefore it will react more violently, so tarnishes very quickly to give a layer of oxide, okay. So these are few important points of your metal when it reacts with water to give metal hydroxide plus hydrogen. One thing you have to like put a star on, because that is important, is that not all the metals will react with water to give metal hydroxide. The ones which lie at the top of the reactivity series, or the ones which are very strong metals, only those will form metal hydroxide. And below calcium, the metals, like for example magnesium, they will react with steam, like for example H2O, which is in gaseous state, and they will form magnesium oxide or metal oxide, not hydroxide, okay. So please note down this. So this was about when metal reacts with water, okay. Now let's talk about when metal reacts with any acid, okay. So a metal salt with hydrogen will be formed. This is your skeletal reaction. So now let's see how it goes. So alkali metals of group 1, which are your calcium, are too reactive to safely add to even dilute acid, okay. They are very violent. This type of reaction is very violent up till calcium, okay. So we are going to study the reaction from magnesium, then aluminium, zinc, okay. This is your reactivity series. Up till here, the most reactive elements, the reaction is very violent, okay. So we do not study that at your level. Here we are going to talk about magnesium, aluminium, zinc, and so on. So how does magnesium react when we add this into dilute HCl, or when we add dilute HCl with this? So strong reaction, bubbles of gas, magnesium disappear, colorless solution formed. Let's see aluminium. Slow to react in cold, but bubbles form on heating. Aluminium disappears. Bubbles of gas, zinc disappear. Bubbles of gas, iron disappear. Pale green solution, no reaction, no reaction, no reaction, okay, because these are the like these lie at the bottom of the reactivity series, hence they do not react easily. Now the reactions. So when Mg reacts with HCl, it will give us MgCl2. This is a simple displacement reaction, right? So because hydrogen lies in the middle of the reactivity series, magnesium is more reactive, hence it will displace and it will form a MgCl2, which is your metal salt, right? Plus H2 gas is released. With H2SO4, the reaction will be MgSO4. Similarly, aluminium reacts to give AlCl3 plus 3H2. Then aluminium reacts with H2SO4. Similarly, we will get Al2SO4 whole thrice, and along with this hydrogen gas. Okay, then with zinc and iron, similar type of reactions will be seen. Okay, so you should know that as we go down the group, the reactivity decreases, and hence there will be no reaction for your copper, silver and gold. Now let's talk about what happens when we react metal with oxygen. So this is going to be your skeletal reaction. It will form metal oxide. Like for example, your Cu plus O2 will form copper oxide. Similarly, Al plus O2 will form aluminium oxide, right? So let's read. Unreactive metals such as gold, platinum do not react with oxygen, obviously because they lie at the bottom of the reactivity series. They will not react with oxygen. Okay, some reactive metals such as alkali metals, which are your calcium, magnesium, calcium, potassium and sodium, they react easily with oxygen. Then copper and iron can also react with oxygen, although much more slowly. When metals react, this is what we will get, magnesium oxide or copper oxide. Okay, then from table you will see that aluminium reacts less slowly. Okay, now here this will react less slowly comparatively. Why? Because aluminium have a layer of oxide on top of it, and that makes aluminium less reactive towards other things. Okay, so let's read this. Aluminium reacts less slowly than would be expected. This occurs because aluminium react easily with oxygen in the air to form a thin layer of aluminium oxide, which is your Al2O3, that extends over the whole metal surface. So because it already has a layer over it, which is of aluminium oxide, that's why it will not react, aluminium will not react easily, because it will not come in contact directly, okay, because it already has a layer of oxide. This unreactive oxide layer is very firmly attached to the metal and does not flake off. The layer acts as a protective coating, slowing the reaction, and that is why aluminium do not get corrode. Okay, because it already has a layer of oxide which is very firmly attached to it. Then only when the oxide layer is removed is the true reactivity of aluminium observed, but usually it is there on it. Okay, if we have to remove it so that we actually react the aluminium with any other thing. It is possible to remove the protective layer of oxide layer, and aluminium then shows the reactivity with acid just below that of magnesium. The reactivity of aluminium when not covered in a layer puts it in the position within the reactivity series just below magnesium but above zinc. So basically it will be somewhere here. Okay, this should be its reactivity position, but then because it has oxide layer over it, that is why it is below. But if we remove that oxide layer and if we wish to react pure aluminium with anything, then it will lie somewhere between magnesium and zinc. Okay, so this was about the chemical properties of metal. Now let's talk about the uses of metal. Before this, I would like you to note down this point. This part is very important, that why aluminium do not react as per the expectation. Okay, so please note down this. Okay, so this is going to be aluminium plus O2, which gives us Al2O3. Okay, why? Because the valency of aluminium is +3 and that of oxide is -2, then we crisscross and we'll get Al2O3. This we already know, right? This is basic. So sometimes if there is such a mistake, you can understand. Okay, next is the uses of metals. Now there are so many type of metals with distinctive properties. Now where are they actually used? Okay, so let's talk about iron first. So iron is very hard but brittle and now replaced by steel. So steel is not any element, but steel is your alloy. What are alloys? We are going to talk about that. It is actually mixture of two or more elements. So the key properties of iron is that it is hard, good conductor of heat, and therefore it is used in construction, girders, then large castings, cooking utensils. Okay, next is your copper. Now copper is very strong but easily bent and it can be given shape. Okay, with high electrical conductivity, and therefore it is used in water pipes, electrical wirings and cables. Next is your zinc, protective coating on iron and steel objects. Okay, so this is their key property, that it can be used as a protective coating on iron and steel object, galvanizing iron and steel to prevent rusting. Okay, so in the galvanization process wherein we coat zinc on the iron and steel object so that we can prevent corrosion. Next is aluminium. Now aluminium is used to make aircrafts and see, construction, aircraft, high voltage power cables, food containers. Why? Because its density is low but its strength is high. Okay, and it is also resistant to corrosion. Why? Because the reason we already know, it already has a oxide layer on it, right, which is very firmly attached to it. Here, firmly attached oxide layer, and hence it will not easily get corroded, right, and therefore it will be used in aircrafts and high voltage power and food containers. Right, now these are some figures which show their uses, like the conducting material, which is your silver or copper. Then aircraft, we know aluminium is used because it is lightweight, or I can say it is low density, but then it is very high in strength. Okay, and also resistant to corrosion. Next, again your wires. Then aluminium sits above hydrogen in the reactivity series. This we have already talked about. Why? Because it has a oxygen or oxide protective layer present on it, and therefore it lies, or it does not react as we expect it to. Okay, next let's talk about displacement reaction. So we know displacement reaction, we have done displacement reaction before, but let's talk about it over here. What happens? This is your reactivity series. Okay, and the one which are at the top are the most reactive, and the one which are at the bottom are the least reactive. Now when we react such elements together, then what happens? The one which is most reactive displaces the one which is less reactive. For example, we have a reaction right here, AgNO3, which is your silver nitrate, when reacts with copper. So two metals have to compete amongst themselves. So Ag and Cu will react. We have to check which one is more reactive. So let's see, Ag is this and Cu is this. Which is more reactive? The one which is above. Okay, so copper is more reactive, hence copper will be able to displace Ag, and it will form CuNO3, which is copper nitrate solution plus Ag, right? So it will easily displace. Why? Because it lies above silver, so it is more reactive than. Now displacement reaction, a reaction in which a more reactive element displaces a less reactive element from a solution of its salt. Displacement reaction between metals and aqueous solution, any metal will displace another metal that is below in the reactivity series. This is because more reactive metals lose electrons. Okay, so what happens? The more reactive elements, it means the more reactive metals, and metals have tendency to lose electron. The more reactive metals means the metals which easily lose electron and form ions more readily than less reactive metals, making them better reducing agent. Okay, because they can lose electron easily, therefore they are reducing agents. What are reducing agents? The one which reduces the other and itself gets oxidized. Okay, so the less reactive metal is a better electron acceptor than the more reactive, thus the less reactive metal is reduced. Right, now there is one more reaction for the reactivity series. Okay, this one, zinc and hydrochloric acid. Okay, here we are talking about zinc and hydrogen. Now let's check which one lies. This is your zinc, this is your hydrogen. Which is above? Zinc is above, right? So it will easily displace hydrogen. So zinc will easily displace hydrogen and it will form ZnCl2, which is your zinc chloride plus hydrogen gas will be released. A reaction looks like this. Okay, where hydrogen gas is released. Then zinc reacts with copper 2 sulfate. Zn when reacts with CuSO4. Now again we have to check the placement of copper and zinc. So Zn and Cl. Cu, sorry, Zn and Cu. Which one lies above? Zinc lies above, so it will easily displace copper. Okay, so ZnSO4, zinc sulfate plus copper will be formed. Okay, and this is how it will look. Initially when we have CuSO4, this is blue colored CuSO4, right? And we have added a zinc metal in it, and then the reaction will take place. A displacement reaction will take place, wherein the more reactive element, which is your zinc, will displace copper and it will form what? ZnSO4. Okay. So, zinc reacts with copper to sulfate to form zinc sulfate and copper. The observed effect on the reaction is that zinc metal becomes coated with a reddish brown layer of copper. Okay. So, this brownish blackish covering which you see, this is actually the deposition of copper. Okay. So, the blue color of the solution fades. What was the blue color? The blue color is that of copper sulfate. It fades. Why? Because now CuSO4 is converting into ZnSO4 and Cu is like coming out, separating out. The solution will eventually become colorless. Zinc sulfate. Zinc displaces copper from solution, so zinc is more reactive than copper. This we already know. You should know the reactivity series properly. Okay, so this was about the chemical properties of metal. If you wish to note down these reactions, then you may do so. Okay, now let's talk about alloys. So what are alloys? Alloys are actually mixture of elements. It can be metals usually, and it can also be few non-metals designed to have the properties useful for a particular purpose. Example, one of your alloy is solder. Now this is an alloy of tin and lead. So two elements, two metals are mixed together when they are in molten state, and then they are mixed thoroughly and we allow them to settle down, cool, and then we get the alloy. Okay, so solder is a alloy which has a low melting point, and usually the metals have high melting point, right? So to curate few properties or to mix few properties of different metals, we tend to make alloys so that we get properties, the suitable properties which we are looking for in that particular alloy. Okay, so solder is the alloy in which the melting point is less or low. So alloys are formed by mixing the molten metals together thoroughly and then allowing them to cool and form a solid. Alloys often have properties that are different to the metals. They are much stronger. Now why they are much stronger? Harder and resistant to corrosion, extreme temperature. So okay, first of all, why do we actually make alloys? That they are much stronger, then harder, and third is they are resistant to corrosion and extreme temperature. These enhanced properties can make alloy more useful than the pure metals. So alloys have different structure to metals. This is the structure of alloy. Why? Because the purple ones are one type of metal and the red ones are another type of element or another type of metal. Okay, this is how they are mixed. In molten state we mix them and then we set them to cool so that we get the solid alloy, right? So element X and element Y, this is the structure diagram of your alloy and this is the diagram of your metals. Here, why we are saying that the alloy is more stronger, harder and resistant? Because it has properties of both the metals, right? Also because metals have a regular arrangement, like you can see over here. They can be, alloys are stronger than pure metals because the layers cannot slide over each other easily as in pure metal. As you can see here, if we'll try to apply force, then it will slide over each other. But in the case of alloy, it will not be able to slide over each other because they are not placed or they are not arranged in a uniform order, right? So this was your alloy and properties. Now look at few alloys. Okay, here are example of your alloys. Strength is not the only property to consider when designing an alloy. For example, solder is an alloy of tin and lead. It is useful for making electrical connections. Why? Because it has low melting point. Okay, because its melting point is lower than that of either of the two separate metals. Okay, now these are the alloys and the composition with which they are formed, or the metals and the particular properties and uses. So first is your brass. Brass is an alloy which is made up from 70% of copper and 30% zinc. Harder than pure copper. Gold, colored, musical instrument and ornaments, electrical connections. So the uses of this brass is that they are harder than copper. First of all, this is the property, and they are used to make ornaments, electrical connections. Okay, then bronze. This is an alloy in which copper is 90% and tin is 10%. Okay, this is harder than pure copper. So statues, bells and machine parts are made out of your bronze. Next is mild steel. So this is made out of iron 99.7% and carbon 0.3%. Stronger and harder than pure iron, therefore they are used in making car bodies. Then stainless steel. iron, chromium, nickel in 74%, 18% and 8% respectively. Harder than pure iron, does not rust, and it can be used to make cutleries because it does not rust. Then surgical instruments, reaction vessels in the chemistry industry or chemical industry. Okay, then your solder, this we have already talked about. Tin and lead, it has low melting point, 50% tin, 50% lead, low MP or melting point, then either tin or your lead, making electrical connection, right? So these are the properties and the uses of the particular alloys and their typical compositions are given over here. Please note down this. Okay, so these were examples of your alloy. Now let's try few questions. Okay, so the first question is, the wiring and connections involved in a domestic electrical circuit must be very safe. Figure shows the structure of a simple domestic electric plug. So this is your electric plug. Here this is your plug case. Okay, so the plug case should be a insulator, so that if we touch it we do not get current. Okay, and the pins should be good conductor of electricity. This much we know, right? Now the properties of four materials are given: W, X, Y and Z, some of which could be used in the home are shown in table. Which of these materials are most suitable to make the case and pins of the electric plug? Choose one of the alternative A and D. Okay, so which material will be used to make the case and which material will be used to make the pins? So first of all, to make the case, one thing is for sure, that it should not be a good conductor of electricity. It should be a poor conductor of electricity, or maybe I can say that it should be an insulator. Okay, so your case, for case we are doing, this is your case, plug case. It should be poor conductivity. So this and this. Now the material should not have less melting point. Otherwise, when electric current is passing through it, it will just melt. Okay, we do not want that. We need the melting point to be higher for the case, so that it is well protected, and hence we can plug it in and plug it out, like we can touch it. Okay, so Y should be my case material. Okay, now let's talk about your pins. So for pins, the electrical conductivity should be good, because through this only the current will pass. So electrical conductivity should be good. This and this can be our answer, but the melting point should be high. Okay, it should be high. So Z is the correct answer. So Y and Z, D is your correct option for this particular question. Next is, which alloy is most often used for the pins of such a plug? Okay, so for pins, which alloy? The alloys which show good electrical conductivity. So which one are those alloys? Let's check. One was your, let's see, one was your brass. Okay, here it was written in electrical connection it is used, and the other one is your steel. Okay, so let's write down here, brass and steel. Okay, these can be used, these alloys can be used for the pins of such a plug. Okay, I hope this is clear. Now let's move on to the next question. Electrical wiring requires use of good conductor and insulation. Figure shows the end of some cabling. Okay, there is a figure. Then which metal is usually used as the wire in this cable? So which metal is used? Copper is used, right? So Cu. Next, what material is usually used for insulation in the cable? So for insulation, what is used? This is the insulation. What is used? Plastic is used. Okay, because it is easier for us to operate the plug or to touch, so that we do not get the current or the electric current. Okay, so it should be an insulator, and inside of this the wires are present which are good conductor of electricity, right? So this is the answer for the question, and here we have answer for this question. So here we come to an end of the part 1 of your chapter metals. I hope it really made you understand the concept, and if you have any doubt, feel free to comment down below and I'll get back to you. I'll be coming with the next part really soon. Till then, stay tuned. Thanks for watching, and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.